Captain Hackobrody, the notorious pirate of the digital seas, had been searching the internet for his next big score. As he prowled the virtual waves, he came across a new web-based game developed by a company called Kubic Games. Intrigued by the potential loot waiting within the game's servers, Captain Hackobrody set his sights on infiltrating the game's network. As he delved deeper into the system, he realized that the developers had made a grave mistake. They had forgotten to secure the game endpoints with HTTPS. This oversight made it easy for Captain Hackobrody to sniff out the network and steal unsuspecting users' passwords and social security numbers. As he made off with the loot, he cackled with glee, knowing that he had struck it rich once again. But little did Captain Hackobrody know, the Kubic Games developers were hot on his trail. As they frantically tried to track down the source of the security breach, they vowed to never make the same mistake again. From that day on, all of their games were secured with the strongest HTTPS protocols available, ensuring that Captain Hackobrody and his ilk would never be able to plunder their treasures again.
I hope you've enjoyed the cartoon, but now for the boring part. Hey folks, this is your favorite DevOps mentor Vladimir, and in the rest of the video I will demonstrate the fastest and easiest way to configure HTTPS on your AWS Elastic Load Balancers. So here's our web-based puzzle game developed by our imaginary friends from the imaginary company called Kubic Games. In one of my previous videos we've built infrastructure for it. Let me demonstrate the source code. And in case you would like to follow this video along, I'll put a link to the GitHub repository in the video description. So today we will improve this app and make it more secure, so it uses encrypted HTTPS instead of plain text HTTP. Before we start coding, let me explain what exactly we will do. We will use a service called AWS Certificate Manager to provision an SSL certificate. After that, we will attach the certificate to our load balancer, so that all traffic between users and the endpoint is encrypted. The load balancer then decrypts the traffic and forwards it over a private trusted networking perimeter within our VPC. This technique is often called certificate overflow or also certificate termination. And just to reiterate, AWS Certificate Manager provisions a certificate. This certificate is installed on our load balancer. Load balancer decrypts the traffic and forwards it to our instances over trusted network perimeter. This setup is secure enough for the majority of cases. However, some situations, for example financial apps with strict compliance regulation, might require full encryption. If you want to learn about the use case with full encryption as well, please support the video by giving a like and subscribing. This will motivate me to move forward and create even more videos similar to this one. And now, without any further ado, let's start configuring our secure website. First, we'll need to register a Route 53 domain. That's because of how SSL certificates work. By design, each certificate is tied to a specific domain or subdomain, and servers not only use it for encrypting the traffic, but for verifying that the user is accessing the legit website that is owned by the entity who actually requested the certificate. To register domain name, go to Route 53, register domains, and press Register Domain. Then you'll need to pick your domain name, provide contact details, and complete the registration process. I will use one of my previously registered domains. Also, if you need more details about how to register a domain, the link to the documentation will be in the video description. Now we can start coding. We will first assign a DNS name to our load balancer endpoint. We will use a data source to obtain information about our registered domain. And a separate Terraform resource for declaring a record itself. It requires the ID of the hosted zone. We'll obtain it from our previously declared data source. In the name field, we'll provide the DNS name that will essentially be typed into the web browser. The type will be CNAME with a time to live of 300 seconds. And we'll point it to our load balancer that we have created in our previous video. Let's run Terraform apply and test it out. First, to make sure that DNS server is returning the right response, we'll use the dig command. If you run this on a fresh domain, it might take up to several hours after the record creation for it to start actually working. Your actual values will be different, but overall, you need to pay attention to the answer section. You must have the original DNS name of your load balancer there and a couple of IP addresses it is resolved to. And when we open the URL in our web browser, it should return the same web page as before. Now it's time to set up SSL. For this, we'll create a couple more resources. The first one is the ACM certificate itself. The domain name property specifies the domain name for which the certificate is being requested. Also, in order to obtain the certificate, we must prove that we own the domain. That's why the process of validation is needed. Usually, there are two options: by sending a special email or by setting a DNS validation txt record in our zone file. We'll pick the DNS option because it's easier to automate it with Terraform. This means the validation option should be set to DNS. To get more context about the validation of ACM certificates, I'll put another link to the description. And to finalize the DNS validation, we'll create a couple more resources. The DNS validation record. The for each block uses a loop to create one DNS record for each domain validation option associated with this AWS ACM certificate. The allow-override property is set to true, meaning that if a record with the same name and type already exists, it will be overwritten. The name record, TTL, type, and zone ID properties specify the details of the DNS record and the zone that is hitting it. And the AWS ACM certificate validation. This resource represents the validation of an ACM certificate. The certificate ARN property specifies the Amazon resource name of the certificate, and the validation record FQDNs property specifies an array of fully qualified domain names that must be created in Route 53 in order to complete the DNS validation of the certificate. This code, especially the block that loops through domain validation options, might seem too complex, but you don't need to worry. There is a decent example in Terraform documentation. The link is also in the description. Now let's run Terraform apply one more time. If we go to AWS Certificate Manager, we will see our brand new certificate, as well as the domain name validation record in our Route 53. Now we'll need to reconfigure our load balancer. We'll set port 443 instead of 80, HTTP instead of HTTPS protocol, and also, of course, attach our certificate by providing its IRN. And don't forget to change the security group rule, so it's allowing traffic on port 443 instead of 80. Apply one more time, and now we can use HTTPS to open our website. That's it for today. If you enjoyed the video, please support the effort by giving a like and subscribing. Also, I'll be happy if you connect with me and say hi on social networks. All links are in the description. Thank you for watching and see you later.